angles if my recording works here. There we go. Okay, so we're going to measure and classify different angles. So first I want to start out with what a ray is. So a ray is part of a line. Okay, so it's just part of a line. Now it does have an endpoint just like a segment did, but it only has one endpoint. Okay, so your ray only has one endpoint. And it extends infinitely in one direction. Okay, so endpoint and then extending infinitely in one direction. So rays are named using the endpoint first, followed by any other point on that ray. Okay, so you always need to start with the endpoint when naming a ray. Okay, so we're going to name a ray right here. So since I'm always starting with the endpoint, I always need to start with M. Okay, that's my endpoint right there. Then I just need any other point on my ray. So I can say O. And just like before, we do need a symbol over the top of those two letters. And we write it as a ray. Okay, so we write that ray over the top of those two letters. Okay, what's another name for this ray? MP. Okay, so again, I started with my end point and found another point along that ray. My next question here, why isn't ray PM an acceptable answer? Why isn't PM an acceptable answer? Talk to the people next to you real quick. All right, so what consensus did we come up with? Anybody? Go ahead, Justin.
Because P is the endpoint, isn't the endpoint.
Because P isn't the endpoint. Okay, so this doesn't start with the endpoint. Alright, so if you choose a point on a line, this point determines exactly two rays. Okay, those are called opposite rays. Okay, so since both rays share a common endpoint, opposite rays are congruent. Okay, so now what it's talking about, if I have a line, right, and I just pick a point on that line, that determines two opposite rays. Okay, so I have one ray going to the right here and another ray going to the left here. Okay? Okay, so those opposite rays form a line. Okay, so we're going to draw a pair of opposite rays, ray PM and ray PX. So notice how when I'm labeling my rays here, both of them start with P. That means P has to be that end point. Okay, so I'll have one ray going to the left, and I know my end point has to be point P. And then I need another point on that ray for M. So here's one of my rays. Now my second ray, since they are opposite, they do need to form that line. We'll go to the right. Okay, again, point P is the end point. Point X has to be somewhere else on that second ray there. Questions on our rays before I get into angles? All right, then an angle is formed by two non-collinear rays. Okay, so that's why we're talking about rays first. Okay, our angles are formed by rays that have a common endpoint. Okay, so here's your angle here. You can see my two different non-collinear rays. Again, non-collinear meaning they're not in the same line. Okay, so why do they need to be non-collinear? I kind of just answered that question for you. If they were collinear, they'd form a line. Okay. Okay, so if they were collinear, they would form a line. Okay, so our different parts of an angle, we have sides and a vertex. So the sides of angles are rays. So if I look over to my picture here, I have two sides. Okay, so to name the sides of your angle, we name rays. So this side right here would be ray xy, starting with my endpoint, going to a point on that ray. My other side here would be ray xz. Okay, we also have a vertex of an angle. Okay, that vertex is the common endpoint. Okay, so our common endpoint of both of our rays here is point X. So we have a vertex named X. So now there are different ways to name an angle. Okay, there are 4 different ways to name this angle right here. So one way, we can use our vertex. Okay, so I could name this angle. We draw a little angle symbol. It's not an L, it's an angle. I could name this angle X. Okay, using that vertex. I could also use this little number within my angle. Okay, you see that number 3 there? Okay, I could also say that this is angle 3. Okay, I like to use the numbers just because it's a little bit easier to find that angle then. Okay, so it's also angle 3. Another way is to use the 3 points on your angle. Now you do kind of have to be specific about what order your points go in. So they want to flow in order to create that angle. So I would say this is angle. I'd start up here at Y, flow down to X, and then over to Z. Okay, so as I say those letters, it should form that angle. So angle Y, X, Z. And again, don't forget that angle symbol. Okay, last way is the same thing we just did, except I'm going to go the opposite direction. Okay, so I can also say this is angle Z, X, Y. Okay, X should always be in the middle, so your vertex point should always be in the center when you're using 3 letters to label your angle. Okay, always in the center. Questions on labeling an angle? All right, then an angle divides a plane into 3 distinct parts. Okay, so we have 3 different parts here. Okay, we have points that are on the angle itself. So in the picture on the right here, our points on the angle would be point Q, point M, and point N. Okay, so that's one of our parts of our plane. So those points Oops, sorry, Q. I was looking at the wrong spot. Q, M, and N. Okay, another part of our plane is the interior points of the angle. So the points where our angle opens up into. Okay, so that's our darker shaded region right here. Okay, our angle is opening into those points. So those points would be S and R. Okay, our last part is the exterior points of that angle, so the points that are on the outside of the angle. Okay, that would be point P and point O. Any questions so far? I don't want to go too fast. Okay, then we're going to do some examples, naming rays, naming angles, stuff like that in our picture on the right here. Okay, so this is a map of a high school. I'm going to do a couple questions with you, and then I'm going to have you do some of them by yourself. So, first question here, name all angles that have B as a vertex. So I want to locate point B. That's right here. Okay, I see two angles that have B as a vertex. Okay, so this first one right here, I have ray BA and ray BD that form this angle. And again, I like to use the numbers in the angle just because it's a little bit easier if they're there. So that angle formed would be angle 1. So angle 1 has B as a vertex. What's the other angle that has B as a vertex? Angle 2. Good. Okay, angle 2 is right here. You can see this ray BD and this ray BC forming this angle right here. Okay, next, name the sides of angle 3. Okay, so I have to locate angle 3. Now when you're naming sides, they are rays, just like we did on the front. You do have to name that ray. Now your end point of your ray has to be your vertex. Okay, so the vertex of angle 3 is C. So my first ray here at the bottom, I could say that is ray CE. My second ray would go up this way, okay, and that would be ray CB. Now, if you kept going and you'd rather use A as your other point on that ray, you could also call it ray CA. But you do need to start with point C. Questions so far? All right, then number 7 here. What is another name for angle GHL? So again, these flow in order. So follow the letters in order to create that angle. So we have from G to H to L. Okay, so that middle letter is your vertex point. Okay, another name for that angle, I could use the number that it's formed. Okay, so that would be angle 7. I could rearrange my letters here. So instead of GHL, I could say it's angle LHG. I'm just telling you different ways. You don't have to write all 3 if you don't want to. Now, since there isn't another ray coming off of point H here, I can also just use my vertex point to name this angle. Okay, so I could also say this is angle H. Now you can only do that if it is a single angle formed. Okay, if I look at point G here, just going to give you an example of what I'm talking about. if I have point G here, it forms this angle 6 right here, but it also forms this angle JGH. Okay, so I can't call this angle G because there's multiple angles formed with that vertex point. Okay, so you can only have one angle formed to use that vertex letter. Does that make sense? Okay. All right. Then number 8, name a point in the interior of angle DBK. Okay, so they're forming this angle here where B is the vertex, and we need the interior. So the interior is opening into. So I just need a point on the interior of that angle, and that would be this point floating over here, and that's point E. Questions? All right, do 9 through 12 with your group.
Angle 4.
Yep.
And inside the angle 5, CB and CG. And then the 12 point on the exterior, CLH. Yeah.
Uh-huh.
What are the words for this?
So you have degrees, 360, and protractor?
Mm-hmm.
Yeah.
But for these.
Oh, for those.
Yeah.
What's a right angle measure? Okay, you got that. Acute is between 0 and 90. Obtuse is between 90 and 180.
And is it 180?
First straight, yeah. Right, I think most people are finishing up. So number 9, what is the vertex of angle 5? That is point C. Okay, that's the vertex of angle 5. Number 10, write another name for angle ECL. So you could have angle ECK. You could have angle LCE, or you could have angle 4. You don't need all 3, as long as you have one of those. You cannot say it's angle C though, okay? No angle C. There are 1, 2, 3 angles, 4 angles formed with that vertex, okay? So you can't say it's just angle C. Number 11, name the sides of angle 5. So you should have ray, CG. Okay, if you didn't use CG, you could have used CJ. Either or, that's the same ray. For the other ray, we have CB, or you could have had CA for that ray. Okay, so again, you don't need both of these. I just wanted to give you both in case somebody did it differently than you. Number 12, name a point in the exterior of angle CLH. So that one's on the outside of your angle. That could be point E or point D. Okay, either or, point E or point D. Any questions on those couple problems I had you do? All right, then moving on here. Angles are measured in units called degrees. Okay, so we have different degrees. The degree results from dividing the distance around a circle into 360 parts. And we use a protractor to measure an angle. So on your protractor here, there's usually an open circle where this point E is on your paper. Okay, that open circle is where you line up the vertex of your angle. So that's why point E is right here. Okay, you line it up with that open circle. Then there's also a line coming off of that protractor from point E. And there's one over here somewhere that you need to line up your bottom ray with. Okay, so that bottom ray should be lined up with those dashes in your protractor. Then to measure an angle, we just have to look at our numbers until our second ray hits that protractor. So sometimes on your paper your ray is shorter. So it does help to have some type of straight edge, like a folder, a ruler, a pencil, okay, anything like that, just to extend your rays so that you can see what number it's hitting on your protractor. Now, since this angle, our ray is on this side, we would look at our bottom numbers to find that degree measure. Okay, so this angle is not 130 degrees. You always have to start from 0 and go up. Okay, so if my ray would have been on this side, I would have started at the 0, which is at the top numbers, and gone up. Okay, so you always want to start at 0 and go up to that number. Does that make sense? Yes? How many of you have used a protractor before? A few? Okay. We'll practice. So we have different ways to classify angles. First one here is a right angle. That measure is equal to 90 degrees. Okay, so right angles are 90 degrees. They kind of look like this. Okay, you have that corner there. Now to signify that it is 90 degrees, we usually put a box in that angle. Okay, so that box right there shows that it is 90 degrees. We also have an acute angle. That measure is between 0 and 90 degrees. Okay, so any degree measuring between 0 and 90. Okay, you can't equal 0 and it can't equal 90. It has to be between the two. Okay, and that one looks kind of like this. It's a little smaller. Okay, and I'll just label it to show, so say it's 30 degrees. Okay, between 0 and 90. An obtuse angle, that measure is between 90 and 180 degrees. Okay, between 90 and 180 degrees. So that one is a little bit larger of an angle. Again, I'll just label the inside here, say it's 120 degrees. So that is greater than 90, but it is also less than 180. The last one we have is a straight angle. That angle measure is 180 degrees. It is just a straight line. Okay, so a straight angle is a line.
You have your books.
Okay.
Page and R. No.
John.
Over
Yeah.
down. And Elena. She sits right there. She's taking a quiz. You can just set it there.
Thank you, Danny.
All right, questions on our classifying of angles here. Okay, so I do want you to just skip over this top part right here. We're going to do some examples before I let you work here. So in the figure, ray QP and ray QR are opposite rays. Okay, make sure you're reading your directions. They usually give you some clue as to how to solve the problem. Okay, so those are opposite rays, and ray QS bisects angle PQT. So I know we didn't really talk about what bisects means, but it splits it into two equal parts. Okay, so you have these two equal parts when something bisects something else. So a couple steps here. First, angle PQR. Okay, that's this one. It's a straight angle. What does that measure? 180. Okay, so it is 180 degrees. Okay, what can you conclude if ray QS, okay, so from point Q to S right here, bisects angle PQT, if it splits it into two equal parts?
Angle PQS and angle SQT are congruent.
Yes. Okay, so your two angles right here are congruent to each other. So angle PQS is congruent to angle SQT. Or TQS, doesn't matter that order. Now, to show that in an angle, just like we had in a line, we can show congruency, right? I used those dashes before. In an angle, we use this little arch right here. And you have to have the same one in the other angle. Okay, so again, same number of dashes means they are congruent. Okay, so that's how you would show that those two angles are congruent to each other. So now, using that information, we're going to look at number 15 here. So if the measure of angle PQT, so the entire angle is 40, and PQS, this angle right here, is 5x plus 15, we want to find the value of x. Well, if I know these two smaller angles here are congruent to each other and the whole angle is 40, what does that angle have to equal? The whole thing is 40, and this is bisecting it, splitting into two equal parts. It's 20, yes. So since both of those angles are 20 degrees then, to solve for x, I would set 5x plus 15 equal to 20. And from here I can just solve for x by subtracting 15 from both sides and dividing by 5. To get x is 1. Questions on how I did 15? No, we're good? We understand? We understand what bisects means? Yep? Okay. All right. Last one here. Now again, this one is still looking at this picture, but your measures are changing in this problem. So angle PQS again, so the smaller one right here, is 2x plus 10. And SQT is 4x plus 6. Okay, and we want to find PQT, so the entire angle. You can just set it down. Thank you. So if I know the measure of my two smaller angles, how could I solve for x? What could I do to solve for x? Set them equal. Okay, so they were congruent, so their measures have to be equal. Okay, so I would set 2x plus 10 equal to 4x plus 6. Okay, I'm going to subtract 2x and subtract 6 from both sides. And divide by 2. Now I found what x was, but that's not what this problem wanted. Okay? This problem wants you to find the measure of angle PQT.
See that angle?
Okay, so PQT is the entire angle. But I'm given PQS and SQT. So what I can do is plug in 2 for x for one of those. Okay, it doesn't matter which one. So if I plug in 2 for x in PQS, I get 14. Now that's just one of these smaller angles. To get the whole thing, what should I do with that number? Add them together, multiply by 2. So I'm going to take 14 times 2 to get the measure of angle PQT is equal to 28 degrees. And I know I forgot to mention what this means. This means the measure of angle, okay, M angle, that's the measure of the angle. Okay, so you use that when you're talking about degree measure. Forgot to mention that. Any questions on how I solved number 16? Do you understand how I set it up, everything like that? Yes? If not, let me know when you're working on your assignment and I'll come around and help.